Okay, we will get started. Good morning. There are so many things as we left off with Ebola virus Wednesday. So many things I think about with this. It is one of a handful within here, and I opened up the OpenStax initially just so I could get those tables to give us some details, but I scrolled up and I thought I'm going to leave it on this for a minute because there's a handful of things that I would like to just discuss as we move through here. So I left you with Ebola. It is one of the viruses that can plague our circulatory system. And we think about hemorrhagic viral infections, super serious, super deadly, potentially highly contagious. I think the world should be thankful that this virus wasn't the pandemic causer that we are hopefully on our way coming out of, right? Or we would have seen huge issues and considerably more mortality than we have seen. So very fortunate. There are all sorts of details about this and some of the others that, again, I'm going to scroll up to just to introduce. I mean, the table will mention them, but I thought we ought to hit it just the littlest bit. And I truly recommend that you kind of scroll through a little of this just to get some details. So there are all sorts of ideas about Ebola. I mean, there have been some novels and movies about Ebola that put it into some perspectives that are semi-accurate, all right? Some of this stuff gets embellished a little bit to try to, shock and awe. You want some of that stuff. There are serious consequences with this and descriptions of people basically bleeding from every orifice and things like that. That technically can happen. And coming in contact with the bodily fluids, the blood coming out of these individuals, highly contagious. All right. So definitely concerns. And this is something that, we think about with a handful of others as, populations of humanity kind of explodes and we start moving into different habitats. The potential to come in contact with crazy novel virus that we've never really thought about is there. And Ebola is kind of something that fits within that category. There's a book, it's called The Coming Plague, that discusses this and a handful of other hemorrhagic viral infections. That's truly pretty fascinating. If you are interested in things like that, I highly recommend that. I think the author, I should have been more prepared with that. I think her name is Lori Garrett, if I remember correct. So Ebola is one we left with last time. And here, just scrolling up, it is a BSL level 4. This is the spacesuit stuff that we showed some images early on in the semester. Researchers dealing with this wear some serious suits to ensure that they're not coming in contact with this. And this is the a type of virus and working in these facilities that I feel like, when you leave the house that morning and potentially tell your significant other, if there is one, goodbye, it might really be goodbye, right? And that's a little bit disturbing to me. That's a job I don't think I really want. So like I said, I want to scroll up just the littlest bit because there are some that, we started this chapter with yellow fever. The next few right through here, not Ebola, all right? But these guys are arboviruses or arthropod-borne viral diseases. All of these I mentioned starting with yellow fever in this chapter. The arboviruses are all transmitted by mosquitoes. But with that said, there are a handful of species of mosquitoes. So it's not just one kind of mosquito and they can infect you with all sorts of stuff. There's handfuls of mosquitoes, and some of them infecting with some types of virus or other things as well, and others maybe something else. We're not going to get bogged down with all of those details, but the text does mention some of the specifics as far as which mosquitoes and some other things. I don't want to go through, I'm not going to read you all of this stuff. My hopes are you've already done that. But I did just want to scroll back up just so we could see the arboviruses and more than just yellow fever. So, and a nice little insert with some of this and details. I think that's kind of cool. Dengue fever is another arbovirus, and it's one that's been described as break bone fever because of the severity of the pain that you feel. It feels as if your arms or legs are literally snapping. Chikungunya is another one that is an arbovirus. So these are the top three big arboviruses that are hemorrhagic infections. So similar, but not exactly the same as what we would be seeing manifesting with Ebola virus. And there are some others within here as well, Marburg and Lassa that are similar hemorrhagic, not listed in this, but they fit as well. Hantavirus, also not one of our bits on the PowerPoint. And that's another one that I wanted to keep on this instead of switching to those PowerPoints. This is something that, I mean, we potentially can start thinking about maybe some possibilities of hantavirus around here. It was first really recognized in the Four Corners area, southwestern United States. So what is that, Mexico, or not Mexico, New Mexico, Colorado, Utah, and Arizona, I believe, right, as they all meet together. That area was where it was first described. Arid, desert-like region. We're kind of in a similar sort of situation, all right? So this is an important one when we think about a handful of different rodents. So deer mouse, white-footed mouse, cotton rat, all of these have some potentials to harbor this virus, and then in turn, we can become infected. We've recognized that just feces, potentially urine as well, from these rodents are what's infectious to us. So there are instances where people potentially go into a cabin or something like that. It's wintertime. Rodents were in there, spring, you decide you want to go in there, you open the place back up. I recognize there's some feces, cleaning that stuff up, sweeping it up, aerosolize these particles, you inhale it, and then ultimately develop the symptoms. With that, there's all sorts of stuff, and we'll hit the table to describe a little of that here in a second. But it can be a hemorrhagic fever and kidney impacts and destruction with that. The pulmonary syndrome is where it's first going to start to establish as you've inhaled these viral particles, and then we progress into the circulatory system. So coming in contact with rodent urine or feces, the feces you're going to recognize, the urine maybe not, but typically if there's urine, there's also going to be feces. So you ought to just assume it's there. All right. The issues I mentioned, sweeping it up, that is ill-advised. You don't want to do that, to aerosolize it. So spraying it down with the 10% bleach solution and cleaning it up with some rags, not to aerosolize it, will help to ensure if those rodents truly were infected, that you prevent yourself from contracting it in the first place. All right. So like I was saying, we typically don't really think about this around here, but I feel like we're in a situation where we're potentially likely to see some of that, all right, with some deer mice maybe harboring it. So caution if you come in contact with it. So I could shift back, but I'm going to leave it on this for just a second because I feel like it's right now it's okay. The next bit after Ebola in the PowerPoints would show us this. So this is an image of HIV or human immunodeficiency virus. There's a handful of things we want to talk about with this. And we've mentioned a little bit of some details with this kind of as we've progressed through. These viruses target the T cells, specifically the CD4 or T helper cells that are the kind of gatekeepers of the immune response, dictating if we're thinking cell mediated or an antibody mediated response. All right. So here we can see kind of a global distribution of the virus global, and this is from 2015, so a handful of years back, but still relatively accurate as we think about some of this. Global prevalence, relatively low, but as we look at some countries or regions, the prevalence is considerably greater, and most of that is in some areas in Africa, West, Central, and East, and Southern Africa. So huge swath of Africa, where the prevalence considerably greater, all right? Upwards of possibly 7% as we look at some of these regions. And there are lots of things that drive these problems, all right? It could be governments that fail to recognize HIV causes issues in the first place, lack of education, all sorts of things can fit to drive these numbers considerably higher than we look elsewhere, all right? So that just kind of puts some stuff in perspective the littlest bit. There's a handful of stages as we think about HIV, and this figure, I'm going to walk you through it so we can see what's happening. It's sort of a little bit busy as we look at this, but bear with me. I think once we start going through it, it will make some more sense. We're looking at a few things on this figure. And one thing I'm going to point out right as we start going on our x-axis, we start off in weeks. Then we've got our little jig jag because we've got a potential bigger time span within here. And we shift from a handful of weeks and now we start talking years after this. All right. So keep that in mind as you're trying to evaluate this. The time scale is 2 different bits as we're moving through here. On this side, we're looking at the T cells and the concentration of them in cells per millimeter cubed. So taking blood and then measuring that stuff, we could also say cc's. On the other, we're looking at the amount of HIV, so the copies of RNA, and this is in per milliliters of plasma. Similar ideas as we look at this, all right? So the T cells are the blue bar, and the red line is our HIV, like the measured RNA or whatever. It's the HIV, all right? So initially, at this bit, at our primary infection, time 0, our T cell levels, we would describe as normal. This is where they should be, all right? So about 1,000, all right? Cells per cubic millimeter, all right? A little more than that, all right? So that's the normal amount. And then we see what happens over the progression of this, all right? So a little bit after our time 0, we've got measurable detection of RNA, all right? A couple of weeks for that virus to get in, to take hold, to start replicating, and then to be detected within the plasma, all right? So the level's really low, all right? The T cell levels really high. The HIV particles start replicating as they infect these T cells, hijacking their machinery, causing the T cells to make more HIV particles, destroying that T cell in the process, releasing HIV. These virions infect more T cells, and we see the blue line, population of T cells, starting to decline as a result of the HIV particles infecting them and destroying. So their line spikes as the blue line plummets, all right? And we cross in here a few weeks into it and we get a peak, all right? At this point, handful of weeks into the mix, maybe pushing about 6 weeks in here, we see our spike in detectable RNA particles for HIV, and we also see a big dip in these T cells. You're going to see some symptoms. You're going to feel signs and symptoms as this is coming down and that's going up. We'll talk some more about that as we start progressing, all right? Then we see some shifts, all right? And the levels of HIV start to decline as we get a little bit of a response against this, and the T cells start to rebound, but they don't come back to where they truly should have been. All right, so at this point, these levels remain elevated, but not at their maximal. All right, so we've got, 600, 700 somewhere in here, not the 1,000 that would be the normal situation. And that persists for a handful of years, potentially, or months maybe, but typically years. And then we start seeing other issues, all right? As we move into this next bit, we would describe, and as I said, there's multiple stages. Here's the first bit, the acute, the latency, and then the last bit over here. When we get to this point, we start talking about the actual full-blown HIV, and it's kind of, or excuse me, AIDS, as we crisscross right here and start seeing these issues, the virus is winning, all right? That's what we're seeing here. So at this point, as we're within this kind of umbrella, this classical latency is when you're feeling pretty good, all right? You don't really recognize these issues, and you've got pretty good communication with those T cells. As the virus starts to get the upper hand, we see this cross where the HIV surpasses the level of the T cells. And at this point, that's when we really start thinking about some of the symptoms that really start manifesting, all right? And we see here the constitutional symptoms opening up avenues as we get up, almost looking like exponential growth as these virus infect and replicate kind of out of control. This is when we really start thinking about AIDS, and it opens up all sorts of opportunistic infections that we have discussed handfuls of them, and we will discuss some others as we progress along. There are numerous infections that are fair game for everybody. And then there are other infections that are kind of these opportunistic situations where your immune response is weakened or depleted, maybe from AIDS, maybe from other things, all right? Organ transplants where your immune response is deliberately depleted opens up avenues for other issues too, all right? So opportunistic pathogens are ones that typically don't impact people with the normal immune response, all right? Things that we might likely come in contact with and you never even know it, all right? But it's this other situation, all right, where your immune response isn't capable of keeping those things in check when they skyrocket. And it's when that stuff starts happening, when weird, oddball, opportunistic infections that shouldn't be plaguing you are plaguing you, that's when these flags go up and they're like, wait a minute, what's going on here? You shouldn't be getting this, but you are, all right? And there are countless opportunistic things, some types of cancers. Kaposi sarcoma is a great one. That's maybe some of the first instances that she got some stuff going on that's super serious, all right? And we progress up here to this, all right? As we look at this and as we think about this, there are all sorts of details that we're kind of glossing over, but we do think with HIV and recognizing it very early, there are potentials to keep this virus really in check. There are treatments that they speculate, and it's probably very true, but you could get to the point that there are no detectable RNA particles, there's no detectable HIV. And at that point, the likelihood of you transmitting that from one person, from you to someone else, is basically non-existent, right? But in science, I don't think they want to just flat out say, you're cured, you're free of this, right? They want to back it up, and they're like, there's a very, very low risk, right? Is it zero? Maybe, right? So it depends, all right? But before we started thinking about, the ability to recognize and treat with mechanisms that we think about today, this really was the course. And after a handful of years, your body really starts to just fall apart as you become infected with all sorts of things. And it was a death sentence. That this is going to be your demise, but it's not really the HIV, it's everything else that you become infected with. That's what kills you. And now, maybe not, all right? I've also read a few things talking about a few people that have potentially achieved some cures with this. Whether or not that's true, not 100%, all right? I have heard of some individuals that have some specific genetic mechanisms that lend to being kind of hyperimmune and not able to contract all sorts of things, and maybe lending to immunity against something like this. There are some hints that some bone marrow transplants from those individuals could potentially cure people, all right? Whether or not that's 100% accurate, also not for sure, all right? And there's some details about, education about it and other potentials. So to the table, which is really why I opened this in the first place, all right? All sorts of different viral diseases of circulatory and lymphatics. So AIDS and HIV up at the top of our list. Some of the initial symptoms, some flu-like symptoms during the acute phase. You just feel a little under the weather, all right? But then you feel better, right? And maybe not recognizing these issues. So you get a long clinical latency and then progressing to AIDS. Fever, weight loss, wasting syndrome, dementia, opportunistic secondary, and a plethora of secondary infections. So body fluid contact, sexual contact, or the sharing of contaminated needles sets the stage for the potential to become infected with that. So through proper education, hopefully we can drive a wedge in the transmission of that in the first place. Tests and drug treatments are potentials with this, and there's a handful of different serological techniques. We didn't go through great detail when we were talking immunology stuff about all of the serology. There's numerous mechanisms, different types of tests that are looking at antigens or antibodies and differing levels of sensitivity or specificity as far as how accurate they may be. And so there's a few tests that are employed with this with some precision, right? We saw the Burkitt's lymphoma, Epstein-Barr virus, a type of herpes virus is the culprit for that. And we can see it causing some super serious issues. There are other things where with Epstein-Barr that aren't as serious with this. And I mentioned the mononucleosis. So that would be, again, circulatory issues with those monocytes being infected. So handfuls that we did mention through the text as we started today, the chikungunya, with this, we see our mosquitoes over here as the vectors, fever, rash, and joint pain. Nothing like the pain you're going to get with the dengue, right? The cytomegalovirus, this is another human herpes. This is type 5, the Epstein-Barr is a type 4. As we said, starting this, with herpes, there are a plethora of different herpes viruses, right? So this one's typically asymptomatic, can cause some non-Epstein-Barr mononucleosis, so different, right? And this is maybe a little more common for adults, right? If we've got other issues, there are potentials for, complications with that. So all of these, we're thinking about contact with fluids, but sometimes that's being transmitted through our insect vectors, our arthropod vectors as well. So the dengue, as I said, the break bone, fever and headache, joint pain, severe, right? Bone pain, again, thinking that, you've broken an arm or leg, hemorrhaging, vomiting. There is the potential for, serious consequences, fatalities with that. So, and we can see a big handful down here where treatment is none. Ebola, that fits with the none. Fevers, headaches, joint pain, diarrhea, vomiting, hemorrhaging in the GI tract, organ failure, and you almost guarantee that it's fatal. Not every case has resulted in deaths, but pretty stinking close. The hantavirus, we went through some details with that, and there's a couple of progressions with that, starting in the lungs and then progressing. The hemorrhagic fevers with the hantavirus, I described some of those details as well, and we can detect with some more serological techniques. Mono, the infectious mono, Epstein-Barr or cytomegalovirus, and we can see some sore throat, pharyngitis, fever, extreme fatigue, like super wiped out, swelling of the lymph nodes, spleen, and liver. And we think about contact with body fluids, saliva, blood, or semen, oftentimes probably saliva. They describe mono as the kissing disease, but other fluids could potentially lend to that as well. And then yellow fever, where we started, we could see issues with this: dizziness, fever, chills, and headache, myalgia, nausea, vomiting, constipation, and fatigue. Severe cases, we have jaundice, rash, hemorrhaging, and maybe death as we move through there. Craziness. All right. Let's see. I'm just going to go to the next. I'm moving right along with this chapter of stuff. Maybe I'll just stay on here. I should just be teaching out of the book the whole time. So moving over to some parasites. There are a good handful that we can think about in here. Malaria, as far as thinking about circulatory system parasites, probably ought to be top of the list. And it starts this unit off, so I would call it top of the list, right? Malaria has plagued humanity since the dawn of humanity, all right? Since our ancestors swung down from the trees, we have been battling this parasite. And the parasite and ourselves, we have co-evolved together, all right? We can see all sorts of details and aspects. There's handfuls of species. Plasmodium is the parasite. There's handfuls of species of Plasmodium that plague humanity. There are some other handfuls that plague other animals, all right? Malaria has been infecting all sorts of mammals and other things. Birds can fit in there too. All sorts of things for a super long time. And we can see some details with that. There are also some potentials with some of these that should or would be thought of as it's in this animal, and then they've jumped over to us, hopping species, all right? And there are a few of our malaria ones that fit within that category as well. When that type of stuff happens, the potential for more severity in the infection within us can be greater. A parasite that we have been dealing with for a super long time really the best idea with those things would be to not cause a huge amount of harm, right? And there is one species of malaria, Plasmodium malariae, that we speculate has been the oldest malaria culprit plaguing humanity. That parasite only infects old red blood cells. Your red cells live for a handful of months, and it's the tail end of those red cells that are getting infected. You don't have huge amounts of those in your circulation. So the levels of parasites that you might see circulating around with those guys considerably lower. Your signs and symptoms are a little less. They're more muted, if you will. All right. You're still sick. All right. But not as bad. All right. Another one that is maybe a little newer plaguing us is Plasmodium falciparum. It's a bad one. That one will infect any aged red blood cell. It doesn't care. All right. And that is bad news. All right. As those parasites get in and infect and replicate, once they rupture those red cells and are released to infect new cells, they infect any. All right. And so your potential for rapid, massive destruction of your red cells is huge. All right. If you want to die from malaria, that's the one you should get, right? It will get you, all right? And there's all sorts of details and, you know, really kind of, I feel like horror story sort of situations as we think about the fever and chills that happen with people infected with it. So these cycles of chills and fevers, 2 days to 3 days, dependent upon the types of malaria. And, you know, as you're getting these chills, you're shivering, teeth chattering. And although I'm sure it's not described in here, it kind of makes me think some sort of possession, some sort of poltergeist type of thing. The kids, because oftentimes it's little kids that are, you know, seriously infected with this stuff, but it doesn't have to be. Adults can have the severity of it as well. But oftentimes in these endemic regions where malaria is present, we think of it as a childhood illness. You get it when you're little, not that you can't have more bouts of it, but it's something that, you know, basically you just kind of expect, right? Which to me is pretty disturbing, right? So there are descriptions of, you know, being in the hospitals with, you know, in your hospital bed in the bout of chills, and the bed is like shaking, vibrating, maybe moving around because you're shivering so bad. That seems pretty disturbing, but the most disturbing bits of it are like as you are shivering and your teeth are chattering because you've got such a severe chill that you just can't stop. People, children, shatter their teeth. They break their teeth out of their mouths because of the severity of the chills. That's hardcore, right? That's some serious infection, all right? And it paints a picture of malaria that just saying, oh, it infects red cells, old ones or young ones, or it doesn't give a crap any ones. That's impressive, but not as impressive as you're going to shiver so bad that you shatter your teeth out. Awesome, right? Super disturbing, all right? So Plasmodium or malaria has a vector to transmit it to us, the mosquito. The Anopheles mosquito is the genus of mosquito that targets us, or the species of mosquito. The mosquito, there's, you know, where do you start? You know, logically, we would start at number 1, right? We could start down here at number 6, right? Which is where I want to start, all right? The mosquito is the definitive host, and we are an intermediate host. When we think about parasites where sexual reproduction is occurring, that host we say is the definitive host. We're the ones that are plagued by it. We're the ones that have the ill effects, but we're not the definitive host, all right? We're just the ones that allow the asexual replication to occur, to ramp up the populations. So the mosquito down here takes a blood meal from an infected person. This infected person is going to develop within their circulation some of these cells of Plasmodium that are the gametes, the sex cells, and we'll hit that here in a second. But these cells get generated. There's other Plasmodium cells that are the parasites, not the sex cells. Those cells go on to infect more red blood cells. But these gametocytes, they're just waiting to be tapped into by the mosquitoes. They don't infect red blood cells. And if your body doesn't, if the mosquito doesn't feed on you and suck those suckers up, your body's going to destroy them in a couple of days, all right? But by the time we get to this point, we just keep making them, all right? So these gametocytes get ingested by the mosquito. Within the gut of the mosquito, the gametocytes, well, they interact. So the male gametocyte, we call it a microgametocyte, and the female macrogametocyte, egg and sperm, really, if you will. Within the gut, the macrogametocyte, the female egg, gets fertilized by the microgametocyte. And within the gut of the mosquito, there are a handful of things that happen. As it makes its way into the stomach, the pH, it starts numerous things. Carbon dioxide, as the blood's getting broken down from the mosquito that's fed upon us, as it gets into the stomach, multiple things, changing pH, digestive enzymes, stimulate the microgametocyte that looks like this to convert, and it exflagellates. It grows some flagella, like a sperm cell, but unlike sperm cells that you might be thinking about from a microscopic view with one little flagella, right? This has got flagella kind of all over the place. And these guys swim around hoping to find the macrogametocyte. Fertilization happens, you've got a zygote. That zygote diploid starts replicating, and as it replicates, and this actually, the zygote, more details, some stuff that could be described as kind of gruesome as well within the mosquito. The zygote bores through the gut of the mosquito and makes its way into the hemocell, like the fluid all around. It's an open circulatory system in arthropods, not closed like ourselves, right? So it gets into the hemocell and it migrates forward in the mosquito, making its way up into the salivary glands, and it goes through a round of replications and divisions. This zygote turns in to this oocyst, all right, going through mitosis and generating all of its progeny inside of it, these sporozoites. So one zygote goes through multiple rounds, creating hundreds of sporozoites within this oocyte that ruptures. They in turn fill the salivary glands with these sporozoites. And as that mosquito comes to take a blood meal, that puts us back to the start at number one, all right? That infected mosquito inoculates those sporozoites into our circulation. As this happens, basically, there's a handful of things going on. Within the tips of these sporozoites are some special enzymes and substances that help it recognize specific things. And the first thing that these sporozoites do, once they make their way into the circulation, is find themselves in the liver, right? And they get to the liver almost immediately. They find themselves there within a day. All of the sporozoites inoculated into us are hanging out in the liver. They infect your hepatocytes. So this is the exoerythrocytic before we get into the red cells. It's the liver stage, right? Our liver cells get infected and the hepatocytes serve as an incubator for more of our Plasmodium. So the parasites get in, replicate, creating merozoites, different stage of the parasite, filling up that liver cell and rupturing, all right? The merozoites, some of them hang out in more liver cells. They flip around and infect a new liver cell, and they can basically cause relapses as they go dormant in some of these liver cells. Not all species of Plasmodium does that, all right? So the merozoites, as that ruptures the hepatocyte, they're released, and the bulk of them are in the circulation. So now we're down here to the erythrocytic cycle. This is really what we think about with malaria in the first place. It's your red blood cells, all right? So the merozoites infect the red cell as they get in there. As this merozoite infects one of our red cells, we get this little ring stage as it starts feeding and sucking up the fluids inside of that red blood cell, eating the hemoglobin. You get this ring stage, and there's kind of a little vacuole that shows up. It looks like a ring, all right? It starts growing and feeding within this, the ring stage kind of matures. Now, all of a sudden, looking at, a blood smear, your red cells should look like this. All of a sudden, we've got red blood cells with something that looks like stinking nucleus in there, right? That's wrong. That should not be happening. Red flag, right? Something's up. Maybe we've got malaria, right? And as we see this, that's definitely an issue, all right? As they replicate, and here we could see the cycle and we can see it shuttling off. Typically, we go through multiple rounds of asexual replication, this erythrocytic cycle, before we ever start shuttling off to create some gametocytes, to in turn ensure that the populations are sufficient so that when we do make the gametocytes, there's going to be boatloads of those suckers released. So when a mosquito does come and feed, you can almost guarantee that little teeny bit of blood she sucks up has got the gametocytes within it, all right? And that's disturbing. Just a little teeny drop of blood can be full of these parasites. That's impressive and disturbing, all right? So they replicate and they go through this asexual replication. We say mitosis right here. We give it a better name if we're really thinking parasitology. We call it schizogeny. And it's multiple rounds of asexual replication, one cell basically replicating repeatedly to give you numbers, right? Dozens of these new merozoites, right? So as they start replicating, we go from the ring stage to this schizont stage, which is just basically another way to name these cells that are full of the progeny, basically, all right? So from ring to full of its babies, right? The merozoites cause that red blood cell to rupture, releasing them into the circulation. And here we see one of them ready to infect. It's either coming out of the liver in this first bit, or it's coming out of these red cells as they've replicated. And we said up above, 2 to 3 day cycle. That's basically what we're thinking about in here. From the time it takes this merozoite to get in, to go through this process, and then to rupture and release those red cells, a couple of days, all right? And as this happens, and we get these into the circulation, when they're in our red blood cells, our body doesn't see the parasite, they're hidden inside. When they replicate and release, now they're visible, and our immune response can recognize them. And the fever and chill cycle is the result of these suckers being accessible, being able to be detected. And we call that not just with malaria, but with any parasite that is visible in the circulation, we call that a parasitemia, right? We talked about the bacteremia and fungemia and all, what parasitemia, the parasites in the circulation, not inside of the cells, but in the plasma, able to be seen by our immune response, all right? So they do this, they replicate, and then like I said, after a handful of replications, populations are elevated, and now it's time to start generating some gametocytes. many of these parasites are still doing this, all right? We don't stop doing this and just start making sex cells. Only a few of these go this route. But after we've created millions of cells to infect millions more of our red cells, that's when a handful of them start going this other way, all right? Creating this situation. And we're back to here to the last bit of it, which I said we're going to start with it as the first bit, all right? And the cycle is completed, all right? So here's a couple of images of a blood smear. Lots of red blood cells that look normal, and then a few that just flat out don't, all right? We've got something going on in there. Here's the ring form, and here's one that's the schizont, where we've got multiple merozoites being generated inside. So a little more developed than this, all right? One quick detail with this, and you can see a little bit of this stuff that looks kind of out of sync, but as we see this here, there is a synchrony. So when these red cells are filled up and ready to rupture, they all basically do it simultaneously. So you get the it's not like, if it all happened just whenever, the symptoms you would see wouldn't fluctuate like this. It would just be kind of progressed. You would have issues throughout. But here, they're all released, you respond, they hide in the cells, and you kind of feel better. That's when the chills start to set in. You get a little bit of reprieve, maybe a day, maybe only a half a day, where you kind of feel normal after the chills stop, and then you're right back to a fever spiking and back to the chills, all right? Again, dependent upon the specific species. All right, another parasite. Cat lovers, anybody? One? Just one? How about tuning in from home? If you're a cat lover, oh man, go look at your cat litter, see what's happening. Toxoplasmosis is the disease. Toxoplasma gondii is the parasite, and the definitive host is your cat, all right? There are a handful of things that can serve as intermediary hosts. We potentially could be classified as an intermediate host. We can be plagued by this, all right? You typically don't recognize that your cat's got ill effects, all right? That's maybe an issue that lends to a greater likelihood of maybe coming in contact with it, all right? Toxoplasma, I don't recall, yep, I thought we had an image. Toxoplasma is impressive, all right? It is something that I wanted to move down to that. I think we'll leave it. We'll leave it up here for a minute, and then I can scroll down. It is something that is kind of ubiquitous, meaning it's all over, it's everywhere. You almost guarantee that cats are probably harboring it, all right? Especially if you've got a cat that likes going outside, maybe hunt some mice or other things, maybe lending to a little more of a chance, but it doesn't have to just be that, all right? There are other opportunities for you to get infected. So pretty common, all right? Highly likely that even those of us that said no cats probably have come in contact with some cats at some point in our lives, all right? And that opens up the door where you potentially have contracted this, all right? Another one that is something that kind of isn't a huge deal, all right? Unless you happen to be pregnant, all right? Then what we would say isn't that big of a deal is now a potential fatal consequence, all right? Not to the mom, but to the developing child, all right? So, and there are a couple of parasites that can kind of do this, and sometimes it's not us that we're thinking of as it doing the damage to cats and dogs. Different parasites can plague the kittens or the puppies either after they are born or during their development, all right? Toxoplasma in this case targets developing fetus from a human, and can cause some serious issues, all right? So we can see down here, again, where do you start? I'd like to start at the litter box. The litter box is a great place for the cats to deposit their feces and the eggs of the parasite that in turn can set their stage. But contamination of food products, water, all of these set the stage for those issues. Let me just quickly run through this and then we will quit. I know I'm about out of time. So we come in contact with this, and if you happen to be pregnant as you're in contact with it, that's when the real issues happen. The parasite can cross the placenta, infecting that child, and it can result in all sorts of issues with the developing child. We can get infected through blood transfusions. We can get infected through the cysts that are formed in animals. We're seeing this. We're not seeing this here because hopefully if you're eating cat, you're going to cook it thoroughly, right? So potentials, all right. Rodents get infected, and there are super cool things. I know I'm out of time, but some parasites alter some host to in turn make it more likely that the parasite gets transmitted to another host. Behavioral adaptations or shifts. And the mouse that should be afraid and terrified of the cat is now super attracted to it. It's in love with the cat, and it especially loves the odor of cat urine. That is, I suppose, an aphrodisiac. The mouse is like, oh my God, I love you. You smell delicious, right? I want to be right by you. I want to hang out by your litter box. So when you come down, maybe we could hang out. And the cat comes down and is like, what the hell? And it eats it, right? It doesn't hang out with that mouse. They're not friends, right? And the cat eats it. And if the cat wasn't infected, it definitely is now, all right? Crazy. That makes me think of Tom and Jerry. And I'm like, Jerry must have had this, right? He had it because he loved Tom, tormented him. He wanted to be eaten. All right. There are other things that I think about with that as well. All right. I'm going to quit with that. And just a couple left in this chapter. We'll wrap that up on Monday. All right, guys. Have a great weekend.